Hi, Assalamualaikum warahmatullahi wabarakatuh. So today me and my group members will present about subtopic from chapter 5, which are specific heat and calorimetry. Before we get started, I would love to introduce my group members and our beloved lecturer. Firstly, I will explain about the heat capacity. What is heat capacity? Heat capacity is ratio of heat absorbed by a material to the temperature change. It is usually expressed as a calories per degree in terms of the actual amount of material being considered, commonly a mole, which is the molecular weight in grams. As we can see in my slide, heat capacity can be defined as the quantity of heat required to raise the temperature of a substance by 1 Kelvin at 1 degree Celsius. The SI unit of heat capacity is joule per Kelvin. Next, the heat capacity of an object denoted by C, and the formula used in this topic is Q equals to C multiplied by the change of temperature. Usually, the heat capacity is already given in the question. Moving on to units of heat, 1 calorie is the quantity of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. Secondly, 1 kilocalorie is the quantity of heat required to raise the temperature of 1 kilogram of water by 1 degree Celsius. Since heat is the energy, the joule is the preferred unit. Then, mechanical energy and heat are measured in the same fundamental units. As a general knowledge, the value of 1 calorie is 4.186 kilojoule, or also can be wrote as 1 kilocalories is equal to 4,186 joule. As an example, let's see some exercise. The question is, the specific heat capacity of 1 kilogram of aluminium is 900 joule per kg degree Celsius. Find the heat needed to increase 0.7 kg aluminium temperature from 28 degrees Celsius to 185 degrees Celsius. The solution is, firstly, we must jot down the formula so that it will be easier to substitute later on. Q equals to M, which is the object mass, times with C, the heat capacity that usually given in the question, and times with the change of temperature. And then substitute the information given and on the formula, and we will get the final answer 98,910 joule.
Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Amira binti Kasim as the second presenter for today. So, I will continue with the specific heat capacity. Specific heat capacity is the amount of energy to raise 1 kilogram of object by 1 degree Celsius. As you can see on the slide, the specific heat with the symbol C is defined as heat capacity per unit mass. If energy transfers to a sample of a substance with mass and the temperature of the sample changes by delta T, specific heat of the substance can be written as C equal to Q over mc delta T. From the definition, we can relate that Q equal to mc delta T, where Q is the amount of heat, m is the mass of the material, C is the specific heat, and the delta T is the temperature change. The unit for specific heat capacity is joule per kilogram Celsius. Make sure you remember this for your examination later. Let's move on to the next slide. As you can see on the slide, there is a table, which is a specific heat table. Please bear in mind that every material has different specific heat capacity. Usually, the specific heat capacity for every object is constant. For specific heat and specific heat capacity, the body could be solid, liquid, or gas. For example, water. If the question asks you, what does it mean by specific heat capacity of water is 4,200 joule over kilogram Celsius? Your answer would be 4,200 joule of heat needs to be supplied to 1 kilogram of water to produce a 1 degree Celsius temperature increase. Some of you must be curious why water has higher specific heat capacity than the metals. So the answer is, metals are a good conductor, whereas a water molecule is strongly bonded by hydrogen bonds. Thus, more energy will be needed to heat the water up than metal. This is why water has high specific heat capacity than the metals. Please remember that the higher the specific heat capacity of an object, the more energy will be needed to heat it up. Now, let's take a look at the example. So, Laila have 3 kg of lead, and she increased its temperature from 40 to 50 degrees Celsius via heating. She knows the energy transferred to the lead is 3,840 joule. So, what is the specific heat capacity of the lead? Let's take a look at the solution. To solve this kind of question, we can use the formula that we have talked about earlier, which is Q equal to mc delta T. The question asks for the specific heat capacity of lead, so make sure you arrange the formula according to what the question wants. It will be C equal to Q over m delta T equal to 3,840 over 3 times 10. We get a 10 from the temperature change, which is 50 minus 40, and the answer will be 128 joule over kilogram Celsius. That's all from me. The next presenter will continue with the calorimetry.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Naziha binti Muhammad Nazir. My student number is 2020464658. Let me continue the presentation. Calorimeter. Calorimeter is the science associated with determining the changes in energy of a system by measuring the heat exchange with the surrounding. In physics class, calorimeter labs are frequently performed in order to determine the heat of reaction, of the heat of fusion, or the heat of dissolution, or even the specific heat capacity of a metal. What are the parts of a calorimeter? Basically, a bomb calorimeter consists of a small cup to contain the sample oxygen, a stainless steel bomb, water, a stereo, a thermometer, the dewar or insulating container, which is it can help prevent heat flow from the calorimeter to the surrounding, and ignition circuit connected to the bomb. So, basically from the diagram, we can see the part of calorimeter, which is we got a stereo, we got oxygen supply, ignition, wires, thermometer, magnifying eyepiece, airspace, crucible, steel bomb, sample, ignition coil, water heater, bucket, and also insulating jacket. So, part of calorimeter. The calorimeter is a small container made of a metal such as gold or copper with good thermal conductivity. For water, let MW, CW, and TW represent corresponding values for water. If TF is the final equilibrium temperature after everything is mixed, therefore QW equal to MW CW in bracket T that TF minus TW. Positive because TF is bigger than TW.
Assalamualaikum, my name is Husna Nadia binti Zainuddin. My matric number is 2020887948 and I am from group 1 AS1202J. For my first section, I will present about for unknown sample. And we know the general equation for heat capacity is Q equal to mc delta T. So for unknown sample, we should also label as X. We have the equation is Qx equal to mx Cx in the bracket Tf minus Tx. Tf means T final. In this situation, Tf has the smaller value than Tx, which then will give us a negative value. Next, isolated system. In an isolated system, the amount of thermal energy of colder object gains is equal to amount of thermal energy of hotter object loses. It also can be written as Q gain is equal to negative Q loss, or Q cold is equal to negative Q hot. As we know, Q is equal to mc delta T. So we just need to put the formula in the both sides. So we get for the Q cold is mc in the bracket T final minus T initial, while for the Q hot we substitute, we get negative mc in the bracket Tf minus T initial. But be alert that some reference book or maybe notebook use Q cold is equal to Q hot. There is no negative in the Q hot. So what we need to do is just vice versa the position of Tf and Ti for Q hot, which is Ti is minus Tf. Next, for the problem section, the question is 100 gram of metal X initially at 115 degrees Celsius is dropped into 1 kilogram of water that is at 25 degrees Celsius. The final temperature for both substances is 50 degrees Celsius. Calculate the specific heat capacity of metal X. We were given the specific heat capacity of water is equal to 4,200 joule per kilogram degree Celsius. So we were given the mass of metal X, which is 100 gram, and we need to convert it to kilogram, and we get 0.1 kilogram. The temperature for the metal X is 115 degrees Celsius, and the mass for water is 1 kilogram. The temperature for water is 25 degrees Celsius. The final temperature, which is Tf for both substances, is 50 degrees Celsius. We were given the specific heat capacity of water, and we need to find the specific heat capacity of metal X. Problem solution. So we use Q loss is equal to negative Q gain. Our Q gain is water because its temperature level is lower than the metal X. So we just need to put the formula for the both side, which is mx Cx delta T is equal to negative mw Cw delta T. So substitute the value we got from the previous question, which is 0.1 kilogram times Cx times in the bracket 115 degrees Celsius minus 50 degrees Celsius equal to negative 1 kilogram times 4,200 joule per kilogram degree Celsius times in the bracket 25 degrees Celsius minus 50 degrees Celsius. So we let the Cx alone at the left hand side, and we bring all the value to the right hand side, and we got Cx is equal to 105,000 joule over 6.5 kilogram degree Celsius, and our final answer is Cx is equal to 1.6 times 10 to the power of 4 joule per kilogram degree Celsius.